All right, so we'll go ahead and get started. Okay, we'll start in prayer. Happy Holy Week to everybody, although this is certainly different than any Holy Week I've experienced. We'll start with a Hail Mary. Hail Mary, full of grace, the Lord is with thee. Blessed art thou amongst women, and blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners now at the hour of our death. Amen. All right. Today, 7th of April, our objective is to find angles of elevation and angles of depression. What that really means is we're going to take what we know about sine, cosine, and tangent and apply it to word problems. Okay? Your homework comes from the workbook, page 106, problems 1 to 4, and those are due in Blackbaud before class on Thursday. Okay, so this is the only way you're going to find out homework. It's listed right here, homework, workbook, page 106. It's due before class on Thursday in Blackbaud. All submissions this week have to be in Blackbaud. That's why I'm trying to get everybody's problems figured out and get everybody online with Blackbaud. All right, so any questions on the homework or the objective for today? All right, so let's just come on over here. And this is really what you might want to take notes on today. For word problems, what I would recommend is a simple 3-step process, and this is the way that I'll present a couple of examples before we do our group work. The first thing you want to do is just sketch the problem so you have a good visual understanding of what you're being asked to do. Okay? Once you sketch everything you know, then you need to find the right triangle in your problem. Because remember, sine, cosine, and tangent only apply to right triangles, a triangle that have a 90-degree angle in it somewhere. Once you find your right triangle, then all you have to do is solve the triangle like we were doing last class. And the only part that you have to solve is enough of it to answer the question you're being asked. You may not have to find all the angles and sides, just whatever it is you're being asked to find. The new term for today is an angle of elevation or an angle of depression. The main thing you have to remember about either angle is it's always measured in regard to the horizon or the horizontal. Okay? We never measure angles of elevation or depression in terms of the vertical. Okay? It's easy to do the way some word problems are presented. You have to measure from the horizon. If you're measuring from the horizon, and you look up like there's a bird in the sky, okay, that's called an angle of elevation. If you're standing on top of a mountain and you're looking down at a lake, that angle is called an angle of depression. Okay, so we always start with the horizon and we either go up or down. If we go up, the term is angle of elevation. If we go down, angle of depression. Right, so let's go ahead and look at an example. And I'm going to give you a minute to read this example and just try to sketch the problem on your own real quick before I sketch it, just to see how you make out. All right, I have an 8-foot ladder and it's resting 6 feet up a wall. I want to know the angle of elevation of the ladder. Okay, so it's the angle of elevation that is formed between the ground, the horizon, and the ladder. Okay, so that's what we're being asked to find is the angle of elevation when an 8-foot ladder rests 6 feet up a wall. So we want to find out that angle from the ground to the ladder. Okay, because this might be an OSHA issue. If that angle gets too small, it might be a safety factor, and the workman may not be able to complete the job with that ladder. He may have to get a different ladder. So there's the problem. Go ahead and try to draw it out. And then we'll go over how to solve it. So the first thing that I would see in this problem is I know I need a horizon. And it looks like the horizon in this problem is simply the ground. Okay? And I have a wall. So I'm going to show my wall. Okay, so there's my wall. And I know I have a ladder. The ladder goes 6 feet up and it's 8 feet long. So I'm going to draw a ladder. Here's my ladder. Okay. Here's my ladder. And I know that it is 8 feet long, and it goes up the wall 6 feet. So I'm not really concerned about the part of the wall that the ladder's not on. So if you want to change your drawing to look like that, it might help you find the right triangle. Because now step 2, now that I've drawn everything I know about this problem, I sketched it out. And now I have to find the right triangle. We make a very important assumption here. We're going to assume that the wall goes straight up. Most walls do. So we're going to assume that the wall is perpendicular to the ground. That's key to this problem because now I can see that this is a right triangle. Okay, I have a right triangle, I know this side, and I know this side, which is the hypotenuse. Okay, where is my angle of elevation? That's what I'm being asked to find. Of the ladder. Well, I want to know the angle. Here's where the ladder meets the ground. So what I'm being asked for is this angle. Okay, the angle from the ground up. Okay, so if we were to look back at what an angle of elevation is, an angle of elevation is measured from the horizon upward. Okay, so that's what I have in this problem, is I have a horizon and I'm measuring how high, how many degrees it is up to this ladder. So imagine I'm standing right here. Okay, I'm standing right here and I want to find this angle. What trig function is in play here if I know 6 and 8? What trig function? If you're standing here, what trig function am I interested in? Sine, cosine, or tangent?
Sine.
Sine. So I know that the sine of the angle that I want is equal to 6/8. Okay. Well, I know that whenever I want to find angles and I know the answer, how I compute that is using the inverse sine. So the sine inverse of a ratio gives me an angle. So go ahead and on your calculator, what is the sine inverse of 6/8? What do you get when you take the sine inverse of 6/8? Everybody get it?
48.59.
Okay, so 48, and we'll round off to the nearest 10, 48.6. So I just answered this problem. The angle between the ground and the ladder is 48.6. The company I work for might say that if the angle of elevation of your ladder is ever below 45 degrees, it's a safety hazard because your ladder might collapse. In this case, it's 48.6. It's above 45 degrees. I can go ahead and safely complete that work. All right. Any questions on this example before we move on? All right, good. So let's come over to another example. This one's going to be a little harder to sketch, and it's going to involve what I think is the more difficult angle to find, and that's going to be the angle of depression. So I'm going to give you just a minute to try to sketch it out yourself. I have a plane that's flying at 8,000 feet above the ground. I'm 24,000 ground feet from a runway. Ground feet means it's not the distance from the plane to the runway. It's the distance, if I was to look down at the ground, it's the distance along the ground from where my plane is to the runway. Okay? So that's ground feet to the runway, and I want to know the angle of descent or depression that the plane has to take to actually be able to hit the runway and not overshoot it or come up short. So try to sketch that problem out. 8,000 feet altitude. Along the ground, it's 24,000 feet from the runway. Okay, that's along the ground as you measure along the ground. Go ahead and sketch that one out. I have a plane. And what do I know about that plane? Well, I know that I have a runway over here. Okay, here's my runway. What else do I know? Well, I know the runway's on the ground, and I am going to make an assumption, a very important one, that the ground is level. Okay, because if we were flying in rocky terrain, that would make a difference. So I'm going to assume that the ground is level. I know that my plane is 8,000 feet high. And I know that the distance along the ground from the plane to the runway is 24,000 feet. Okay, this is what we mean by ground feet. Okay, how do we go from where the plane is above the ground to the runway? That's the 24,000. It's not this slant distance. That's obviously going to be more than 24,000. Right, so there's my problem. What is it that I'm trying to find in this problem? An angle of depression. Well, where am I in this problem? I'm in this plane. Okay, so where is the horizon in this problem? The horizon, if I'm in this plane, the horizon is right here. Okay, that's the horizontal from where I am at. What am I trying to find? The angle of descent. If I'm flying this plane, how much do I have to tip the nose down to be able to hit the runway? Okay, so I'm trying to find this angle right here. And sure enough, that is an angle measured from the horizon down. The problem is the angle I'm trying to find isn't in what looks to be a triangle here. So I need to figure out how I'm going to solve this problem. Well, I've now sketched it. I know what I'm looking for, and I've written down everything I know about this problem. The next step is to find the right triangle. How do we measure the height of something? When we did the flagpole exercise, we measured our height by making sure that we were standing straight up. So can I assume that this is a 90-degree angle? Yes, because distances are always measured perpendicular to the ground. Okay, you're always going to stand up straight when you measure your height. There's my right triangle. So here is a right triangle. The problem is my angle I'm looking for is not in here. So am I stuck? Well, not really. There's two ways to do this problem. The way I like to do it is I like to keep the angle I'm looking for in the problem, in the triangle I'm looking for. If I drew another perpendicular line here to the ground, and I filled this in, isn't this whole shape right here just a rectangle? Because this is 90 degrees, this is a rectangle, and we already talked about if you have a diagonal of a rectangle, it splits the rectangle up into two congruent triangles. Okay, but that's just review. Let's take a look at this. This angle I'm looking for, let's call it X. Isn't that angle the same as that angle? Would these two angles be the same?
Yes.
Why? Yes, because aren't these parallel lines? Parallel lines cut by a transversal have congruent alternate interior angles. Okay. So now I'm set up to work this problem either way. If I recognize this is a right triangle, here's my triangle. Okay. What do I know about this triangle? There's my angle of descent. I'm in a plane. I need to go down to get to the runway. How far is it from the plane to the runway parallel to the ground? Well, that's 24,000, right? How high is the plane above the runway currently? 8,000. Okay, so now I have enough information to find X because I have a right triangle, sine, cosine, and tangent are in play, and I know two legs. So what trig function am I going to use to get X if I know these two sides, sine, cosine, or tangent? Well, which one of these is my hypotenuse? The hypotenuse is always across from the 90 So in this triangle, this is my hypotenuse.
Where are we standing at?
We're in the plane, okay? We're in the plane. We're the pilot. So if we're the pilot and we want to know how much I have to decrease the plane, I'm here. I'm trying to find this angle, X. So I'm standing right here. So what trig function would that be?
Tangent.
Tangent. So if this angle is X, I know the tangent of X equals what goes up top. Which one would go up top?
The adjacent.
Tangent is what? Opposite over adjacent. So if I'm standing here, what's my opposite side?
8,000.
8,000. I'm just going to put 8 over 24. Why can I do that? Why can't I just cancel these zeros out?
They cancel each other.
They're going to cancel each other out. 8,000 over 24,000 is just 8 over 24. I could write 1 over 3 too, because I know 8 over 24 reduces to 1/3. So if you want to make the problem a little easier to work with, you can do that. So if I'm looking for the tangent of an angle whose ratio is 8 over 24, I know that if I take the inverse tangent of a ratio, it will give me the angle. Okay, so go ahead and do that and tell me what angle you get. What angle do you get?
18.43.
So 18.4 degrees. Okay, so we just solved that problem for the pilot. If the pilot wants to hit the runway, he needs to do an angle of descent of 18.4 degrees. Okay, and trigonometry is actually how all the instruments on the aircraft figure out things just like this. I mean, this is a good real world example of the use of trig. You know, the airplane instruments do this much quicker than we just did. They do it instantaneous. So the pilot just says, oh, I got to do an 18.4 degree angle of descent. Okay. But notice if I had looked at this triangle and got this angle, I would also get 18.4. Because if I'm standing here and looking up at the plane, okay, the angle of elevation would be 18.4 degrees. And I would find that by still doing the inverse tangent, because if I'm standing here, that's the opposite over adjacent. So if you wanted to solve the problem, if this makes more sense than this triangle up in the sky, because you know along the ground you're 24,000 and you're 8,000 high, if you find the angle of elevation from the runway up to the plane, that angle is going to be the same as the angle of descent if you're in the plane. And that makes sense if you think about it, because these are parallel lines and this is a transversal. These are nothing more than alternate interior angles. So they're both going to be 18.4. So how should you solve the problem? It all depends on how you draw it. If this makes more sense to you because your reference point is being the pilot, go ahead and draw it out. Use this triangle. If this triangle makes more sense because you're on the ground and you know this is 24,000 and it's 8,000 high, and you understand that this angle is the same as the angle of descent, go ahead and solve it, finding that angle. Okay. So word problems are a little more difficult because you have to take something like this, draw it, get a good sketch, start labeling things, and then you have to find the right triangle that's going to help you solve the problem. And then you get to do what we did last week of just doing the mechanics of using the right operation, the right function, and finding the answer. Any questions on this example? All right. Let's see. How many people, did anybody new hop on since I started? Let me look around.
I think so, sir.
So we have about 20 people, so maybe 4 groups or so. Okay, so what I want to do now is one thing that Zoom will do is it will do breakout rooms. All right, so I'm going to split you up into groups of 4. What I would ask every group of 4 to do is to come up with your own word problem. Okay, so you need to come up with this up here. Okay, and you're going to read it to the rest of the class, and the rest of the class is going to try to solve it. So when you're working in your breakout room, you need to come up with the problem, and you need to come up with the answer to the problem. Okay, so then what you're going to do is you're only going to give the problem to the rest of the class, and they're going to see if they can come up with the same answer. And maybe I'll even keep track by groups to see what group does the best. So does everybody understand what we're going to do? When I break you up into your working group, the only thing you'll see is you won't see everybody else in class. You will only see the people in your group, and you'll get a little message that says, click here if you want to join this group. Okay, go ahead and join that group. Come up with a group leader that's going to present the problem. And then at the end, I will be checking. I have the ability to go from group to group to see how you're doing or to see if you have any questions. Okay, so there'll be a group work grade associated with this. When I drop in on your group, if y'all are working, you get an easy 100 for classwork today. Okay, and it also gives you a chance to ask questions. At the end, we'll wrap up, and you'll be told that your breakout group is ending, and you're going to have to come back and join this meeting again. When you come back and join this meeting, that's when I'm going to ask you to present your problem to the rest of the class, and we're going to try to see who can find the answer. I'm not going to put them up on the board here. You all are going to work to try to figure out the answer for your group, maybe get a point for your group. So you will need a piece of scratch paper. So go ahead and get that now if you need it. I'm going to stop the recording because group work or breakout rooms are not recorded. All right, so group 1, I think, Gary, that was your group, right?
Yes, sir.
I think so, sir.
Okay, you have your problem? What we'll do is you'll go ahead and read your problem to the rest of the class.
Jack has our
Everybody else-
problem, but we had trouble. It was really confusing with it. We couldn't figure out the depression thingy.
Okay, well, let's read it and see if
But-
somebody else can. If you have your problem, go ahead and read it for the
No,
rest of the
our
class.
problems all messed up. But it's okay.
Okay, well, see if you can figure it out to make sense, and we'll come back to you.
All right.
Group 2, that was
I don't know if I figure out the mix.
Nathan. That was your group, right?
Yeah.
Okay, what's your problem?
Xavier has it written down.
Oh, Jack. Let me try something real quick, Jack. Before you. Hold on.
All right, so Xavier, you have the problem? Are you muted, Xavier?
Yes, sir, I have a problem.
Okay, go ahead and read it for the rest of the class, and we'll see if we can solve it.
All right. An airplane climbs at an angle of 11 degrees with the ground. Find the ground distance it has traveled when it has attained an altitude of 400 feet.
400 feet, okay.
Yes, sir.
All right. So find the ground distance, takes off at an angle of elevation of 11 degrees. It's climbed to 400 feet. So go ahead and try to solve that. As soon as somebody thinks they have the answer, go ahead and let me know.
You throw these away.
Hey, anybody get an answer? Okay, Xavier, you're still there?
Yes,
All right,
Sir, I'm
read,
still here.
read your problem again.
an airplane climbs at an angle of 11 degrees with the ground. Find the ground distance it has traveled when it's attained an altitude of 400 feet.
So this is what the diagram would look like. It's climbing at 11 degrees. It has a height of 400 and you're trying to find the ground distance. All right. So TJ, this gets back to your question. If I know this is 11 degrees, I'm going to stand here. Okay. If I'm standing there, okay, what side is my hypotenuse? Well, I know this is 90 degrees because I always measure elevation from the ground perpendicular. You stand up straight when you measure your height. So this is always the hypotenuse. It's across from the 90-degree angle. If I'm standing here, is this the opposite or the adjacent side?
Opposite.
Opposite. Is this the, and then this would be the adjacent side, right?
Mm-hmm.
So what I know is the opposite side. What I'm trying to find out is the adjacent side. So we have this acronym, SOHCAHTOA. Okay. The S, that's cosine, sine, cosine, and tangent. I know the opposite and I want to find the adjacent. So that means I know the opposite and the adjacent. Where up here do you see O and A? Do you see O and A here, here, or here? Here, right?
Let me
So I want to use the tangent. Does that make sense?
Yes, sir.
So the tangent of where you're standing, okay, the tangent of where you're standing, I'm standing at the 11 degrees. So the tangent of 11 degrees is nothing more than a ratio. It's the opposite over the adjacent, 400 over X. Why am I trying to find X? Because Xavier said, how far along the ground did he travel? That's ground distance. How am I going to solve this? I make it a proportion. I cross multiply. X times tan 11 is equal to 1 times 400. Now to get X by itself, I divide by tangent 11, because remember, tangent 11 is just a number in your calculator, right? So X is, what is 400 divided by tangent of 11? Anybody get an answer for that?
That's a thing.
400 divided by tangent of 11.
I got, okay. 400.
2057.9.
Okay, 57.9. So if we round off to the nearest foot, it would be 2058, okay, or just over 2 kilometers. Okay, so that's how far he traveled. Or did you say feet or meters? Well, it doesn't matter. If this is feet, this is feet. If this is meters, this is meters. Okay, so that's how you would solve that problem. Okay. I spent some extra time to go over that problem completely, mainly because I wanted to answer the question earlier. Unfortunately, that means we probably do not have time to do any other examples from today. So let me just come on over here. Make sure that for homework, okay, there's a couple more word problems. It's only 2 word problems, numbers 3 and 4. So it's not that much homework, but it'll give you a good review of how to make your sketch, find the right triangle, solve the right triangle. Okay, that's the 3 steps that you want to take in these problems. Okay, so we only have about a minute left. Does anybody have any? And everybody did well on the group work, so you'll get a good classwork grade for today. Any other quick questions before we leave for today? Remember, this is the only place that homework is posted, so you have to write that down, and you have to get it in on Blackbaud by Thursday. And several of you have quizzes to get into me, so make sure you get those in, reformat, or whatever you have to do. That's your mission for today. Any other questions?
Mr. Ramosi,
Yes.
for like this type of work, like for the Sakatoa stuff, you can't have like in the ratio a bigger number be bigger than the bottom number, right? The top number be in the ratio.
The top number in the ratio can only be bigger than the bottom ratio when you're doing tangent. Okay, because if you think about it, for sine and cosine, what's in the bottom? The hypotenuse. And the hypotenuse is always the longest side of a triangle.
Okay.
Okay, but in tangent, your top can be bigger than your bottom. All right, good question. Okay,
Mr.
we're out
Obrowski,
of time,
Mr.
guys.
Obrowski.
If you have additional questions, please stay on, but I know that some